Hello friends, the question is verify that matrix A into adjoint of the matrix A is equal to adjoint of A into A is equal to determinant of A into I, where I is the identity matrix, when the matrix A is given by 2, 3, minus 4, minus 6. Okay, so friends, first of all we take the given matrix, and the first thing which has to be done is to calculate the adjoint of this matrix A. Okay, so for this we are going to calculate the cofactors of each element. Okay, so A11 would be equal to minus 1 to the power of 1 plus 1. M11, that is the minor of the element, would be equal to minus 6. So this will be equal to minus 6, as this will be equal to plus 1. A12 is equal to minus 1 to the power of 1 plus 2 into its minor M12, that will be equal to minus 4. So this will be equal to minus 1 into minus 4 is equal to plus 4. So A12 is equal to 4. Similarly, A21, the minor of this element, cofactor of this element. So M22 is equal to 3, that its minor would be equal to 3. So A21 would be equal to minus 1 to the power of 2 plus 1. This will be equal to minus 1 into 3, that will be equal to minus 3. A22, that is cofactor of this element, minus 6. This will be equal to minus 1 to the power of 2 plus 2. Its minor would be equal to 2. So this will be equal to 1 into 2, that is equal to 2. Now, adjoint of a given matrix A11, A12, A21, A22 is equal to is given by the matrix formed by its cofactor, and the cofactor of the elements of a row are written in column. Okay, so we are going to get the adjoint of this matrix A as equal to minus 6, 4, minus 3 and 2. Okay, so now we are going to calculate individually the value of A into adjoint of A into A, and if the values of all these three terms are equal, then it would be verified that this expression holds. Okay, so A into adjoint of A is equal to the matrix A, that is 2, 3, minus 4, minus 6 into the matrix minus 6, minus 3, 4, 2. Now we are going to multiply these matrix and we are going to obtain 2 into minus 6, 3 into 4. Okay, further 2 into minus 3, 3 into 2, minus 4 into minus 6, minus 6 into 4, minus 4 into minus 3, and minus 6 into 2. So this will be equal to 12 plus, this will be equal to minus 12 plus 12, 0. This will be equal to minus 6 plus 6, 0. This will be equal to plus 24 minus 24, 0. This will be equal to plus 12 minus 12 equal to 0. So all the elements would be 0. So A into adjoint of A would be equal to a null matrix of order 2. Okay. Similarly, adjoint of A into A would be equal to minus 6, minus 3, 4, 2. That is adjoint of A into the matrix A. This will be equal to minus 6 into 2 plus minus 3 into minus 4. Okay. Further, minus 6 into 3 into minus 3 into minus 6. 4 into 2 plus 4 into minus 2. 4 into 3 plus 4 into plus 2 into minus 6. So this will be equal to 12 minus 12. This will be plus 12, 0. This will be minus 18 plus 18, 0. This will be 8 minus 8, 0. This will be 12. This will be minus 12, 0. So this will be equal to a null matrix of order 2 again. So these two terms are equal. Now we shall calculate the value of this determinant of A into identity matrix. Okay, and this will be equal to the determinant 2, 3, minus 4, minus 6 into the identity matrix of order 2. Here we have taken identity matrix of order 2 because this equation involved the matrices of order 2. Okay, so we have taken the identity matrix of order 2. If the order had been different, we would have taken a different matrix or as an identity matrix. Okay, if the order was 3, then we would have taken the identity matrix of order 3. Okay, So now we are going to solve this determinant and multiply with this matrix. So this will be equal to 2 into minus 6 minus 4 into 3. So this will be equal to minus 12, this will be equal to plus 12, so this is going to become 0, and this matrix multiplies, so this will be equal to 0 into this matrix 1 0 0 1. And you know, if a constant multiplies with a given matrix, it multiplies with each element of the given matrix. So 0 into all these 4 elements would give us 0 at all these 4 places, and hence we can say that the determinant of A into identity matrix is equal to null matrix. So this verifies, this proves that the given expression is correct. Okay
friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.